Hello, welcome once again to ASM online math class. In this video, we are going to discuss the scalar or dot product and cosines of angles between two vectors. If you don't call it the scalar product, you are free to call it the dot product. They are the same thing. Okay, and also the cosines of angles between two vectors. These are the things we are going to discuss. If it is your first time of viewing, consider subscribing to my channel. It will always notify you when I upload a new content. Now, if you want to talk about the scalar product of two vectors, let's say we are talking about vector A and B. So the scalar product of vector A and B, written as A dot B, is equal to the product of the modulus of A and the modulus of B, then multiply by the cosine of angles between them. So A dot B is something as modulus of A multiplying modulus of B with the cosine of angles between them. Hence, if I want to make the cosine of angle subject of the formula, I can now write that cos theta equals A dot B all over modulus of A dot modulus of B. So this is how to get the cosine of angles between the two vectors, say A and B. Now, in the process of finding the dot product or scalar product of two vectors, we normally encounter these components of vector I, J, K, etc. for instance. So the key is that when you have I multiplying I is equivalent to 1, J multiplying J is equivalent to 1, but I multiplying J, once they are different, either IJ or JI, IJ will give you 0. Okay, so once they are from different components, it's going to give you 0. So these are the key things you need to know when you try to multiply two vectors, that is getting their dot product or their scalar product. Because if you have I times I is something as 1 times 1 because their modulus are 1 and 1, then cos the angle between I and I is just 0 degrees because they are the same, no space, they are parallel to each other. So now, and because 0 will give us 1, 1 times 1 is just 1, but j times j is something as 1 times 1 because their modulus are 1. Also the angle between them is 0, this will still give us 1, but I and j are different. The angle between them will just be 90 degrees because they will appear to be like this. The angle between them is just 90 degrees, and cos 90 is 0. 0 times all these things here will give us 0. So these are the key information you need to know. Now let us employ these things we've learned in dealing with this particular problem here. Okay, here we have that we should find the dot product and cosines of angles between the following pairs of vectors. For the first one, number I, we have A as 3I minus j, and our B as 5I plus 2j. Now, first of all, let us get this dot product which they want us to get. Dot product A dot B is something as multiplying the two vectors. We have 3I minus j into 5I plus 2j. So let us open the bracket and see what we shall get. So A dot B will now be 3I times 5I is 15I squared. 3I times 2j will give us 6ij, minus j times 5I will give us minus 5ij, and minus j times 2j will give us minus 2j squared. And for the key information I gave you, you should know that I squared means I times I, which is 1. So this is just 15 multiplying 1 plus 6ij minus 5ij is just ij remaining, minus 2 bracket. When I see j squared, it is still 1 because j squared is j times j. So finally, we shall have a dot b equals 15 times 1 is 15 plus ij is 0 because they are different. Then minus 2 times 1 will give us minus 2. At the end of the day, you see that a dot b is now 15 minus 2, which will give us just 13. And the scalar product of the vectors A and B is giving us 13. Now let us get the cosine of angle between the same vector. We knew that cos theta is something as a dot b over modulus of a times modulus of b. Okay, now we have got our a dot b as 13. So the things we need now are the modulus of a and the modulus of b. Now look at a here. The first is x, y, the second is y, x and y. And from the formula, you should know that modulus of a is the same thing as square root of x squared plus y squared. Okay, so modulus of a will now give us square root of our x is 3 squared plus our y is minus 1, coefficient of z, so it will be minus 1 all squared. So modulus of a is something as square root of 3 squared is 9 plus 1. So modulus of a will give us root 10. When I add 9 and 1, I'm getting 10. Now let us get the modulus of b. Now modulus of b is the same formula. Look at b here. I shall have it as square root of 5 squared plus 2 squared. And 5 squared will give me 25 plus 2 squared is 4. So I'll wipe off here and continue. Now the modulus of b is now square root of 29, because when I add 25 and 4, it will give me 29. And finally, I'll apply the formula that cos theta equals a dot b. A dot b is now 13. So I have 13 over modulus of a gave me root 10. So I have root 10 times modulus of b, which I've got here as root 29. This is the same thing as 13 over 10 times 29 will give us root 290. If you wish, you can rationalize this. This is okay, but you can rationalize by saying times root 290 all over root 290. So finally, cos theta will give us 13 times root 290 is 13 root 290 all over root 290 times root 290 is just 290, because when you multiply together and still find the square root, you get the same thing. Okay, so let us take the second question. So in the second question, we'll have vector a as I plus 4j and vector b as 2I minus 3j. So let us get a dot b, the dot product. So a dot b will give us I plus 4j multiplying 2I minus 3j. Okay, now to open the bracket, we have to have I times 2I, which is 2I squared. I times minus 3j is minus 3ij. 4j times 2I will give us plus 8ij. 4j times minus 3j is minus 12j squared. Okay, now a dot b will give us 2I squared minus 3ij plus 8ij will give us plus 5ij, then minus 12j squared. Now we've known that I squared is 1, j squared is 1, while ij is 0. So we have to substitute. We now have 2 brackets 1 plus 5 bracket 0 minus 12 bracket 1. So a dot b will give us 2 times 1 is 2 plus 0 minus 12. Now finally, we shall have that our a dot b will now be 2 plus 0 is 2, and 2 minus 12 will give us minus 10. So the dot product of the vector AB is just minus 10. Now since we've got the dot product, let us get the cosines of angles between the two vectors. Already we've known that cos theta is equivalent to a dot b over modulus of a multiplying modulus of b. Already we've got a dot b, so the things we need now are modulus of a and modulus of b. So let's get modulus of a. Modulus of a is just square root of x squared plus y squared. So modulus of a will now be square root of, for a, my x is coefficient of I is 1, y coefficient of j is 4. So I have it as 1 squared plus 4 squared. Modulus of a will give me square root of 1 plus 16, because 4 squared is 16. When I add up, I'm getting root 17. Okay. Now, having got modulus of A, I'll have to get the modulus of B. Now, modulus of B will give me square root of, look at B here, x is 2 squared plus y is minus 3 squared. So modulus of B is the same thing as square root of 4 plus 9. I'll wipe off here to continue. So modulus of B will give me square root of 4 plus 9 is just 13. Okay, now having got modulus of A, modulus of B, and A dot B, so let us substitute them in this formula to get the value of cosines of angle between them. So our cos theta will now be A dot B, which is now 10, as you can see there, all over modulus of A is root 17, times modulus of B, which is now root 13. When we take the product, we shall get, remember this A dot B is minus 10, not just 10, okay? Minus 10, not 10. So, and we shall have it as minus 10 over root 17 times 13 is 221. So we shall have root 221. I can rationalize this. Hence, I shall have that cos theta equals minus 10 over root 221 times root 221 over root 221. So finally, I'll have that cos theta equals minus 10 times root 221 is minus 10 root 221 all over root 221 times root 221 is just 221. So this is just the cosine of angles between the two vectors. So I plead that you should subscribe to my channel if you've enjoyed what you've watched, so that you not miss anything coming from my subsequent videos on vectors, because I'm going to take vectors line by line. In the next 2 days, another episode of vector will come out. Thank you so much for your audience.